this video, we explore industrial automation, a field so powerful that it turned the humble conveyor belt into the backbone of modern world and convinced engineers everywhere that the best human intervention is minimal human intervention. No offense to the humans watching this video. We are still useful, mostly for defining the conditions, and of course, still very important. People often say automation is replacing human jobs. Another opinion is not yet. We built these machines so that we don't have to work, and now we are spending all the time maintaining them. So, honestly, the job is very much still there, and those cables are bringing in some data and sending away commands to different machines. Now, think about the last time you used an app while resting in an air conditioned room or saw a package delivered at your home. Behind every one of these moments, there is an automated system making it happen. Somewhere out there, right now, a robotic arm is sorting packages it has never touched before. A system, with the help of sensors and different actuators, is making decisions faster than we blink. And a valve in an industry is opening and closing based on logic that an engineer carefully designed for that exact purpose. This is automation in action. So, automation is no longer a specialty locked inside factories. It runs through healthcare, agriculture, aerospace, and every industry you can name. This is the foundation. Once you understand how these systems think, sense, and act, you will never look at the world around you the same way again. So this video will take us from very foundation, sensors, actuators, IoT, and decision making systems, all the way to the intelligence behind modern industrial control.
The topic of today's session is industrial automation. And before we start, I want you guys to imagine something. Imagine you are driving a car in a street and suddenly a kid jumps in front of you. So, what will you do? Will you apply the brake or further accelerate? Of course, brake apply. If we want to understand this process, what we did first, we used our vision sensor and our brain processed it and decided to apply the brake, and accordingly different signals are sent to different muscles so that we can apply the brake. This is how the automation in industry is working. So through this seminar, through this session, we will understand how industrial automation is working and how it has evolved throughout different industrial revolution. The first question is, what is industrial automation? To understand this, we have an image here. This shows an old industrial setup where we see that workers manually are moving different kind of boxes and sorting them accordingly, and they are inspecting each box separately in order to sort it. After some advancement, motorized conveyor belts were introduced. In this, the movement of boxes from one place to another place is little bit easier than before, but still the workers are manually inspecting them and organizing accordingly. With further advancement, we have now sensors and actuators and different robotic systems. What they are doing, that the inspection process which previously done by workers, now it is being done by different sensors, and they are moved accordingly through actuators and robotic arms. So if we see all these scenarios collectively, what we are seeing that from manual to automated system, the number of workers has reduced, the efforts given by workers has reduced, but the performance or operational performance has significantly increased. So this is how industrial revolution has has been observed. So what is industrial automation? Use of control system to operate industrial process with minimum human intervention, right? So this is how we can uh, define industrial automation. For the foundation of automation, this is a very good example. In our body, we have different sensors. We have eye, we have skin. Through skin, we can feel the touch, right? And through these sensors, data is going to the brain, and brain processes it, and after the processing, the brain decides what action has to be performed, and accordingly different signals are sent to different muscles. Recall the first example, that when brain decided to apply the brake, it sends different signals to our maybe leg and foot and arm and hands, and accordingly collectively we apply the brake. So if we take this example to industry, then we have different sensors in the industry. In this example, we can see temperature sensor. We have a controller. The temperature sensor's information is going to the controller, and controller is designed by the engineer, whoever has designed it, and based on that design, the specific any specific action will be performed. For example, if temperature rises from 30 degrees centigrade, then the fan will be turned on. So fan in this example is actuator. So far we have seen, uh, we have heard three main components: sensing, decision making, and actuation. So what is sensing? We have in industry, we have different kind of sensors. We have sensors for temperature, we have sensors for pressure, we have sensors for flow, either that is for fluids or for air. And uh, once we have different sensors available, the data coming from sensors will go to the processors, and the processor will do the decide whatever action, and that action will be performed by different actuators. And in order to perform that actuation, that physical motion, the controller has to send different signals to all the actuators. So the movement and transportation of the data through in this system is done by IoT today. You have heard about IoT, right? So what is things in IoT? Let's see that. Uh, if we see here, we can see a sensor. We can see conveyor belt. So there is a motor inside that conveyor belt. We have a robotic arm. So these entities are things in IoT, and those things are either generating data. Based on that data, the processor will be or controller will be deciding something, and after the uh, after the decision, based on the signals from the controller, actuator will perform some action. So all these things collectively will be communicating through some protocol. That protocol, communication protocol, can be wired and that can be wireless, and there are several wired and wireless protocols available. Those can be utilized for IoT, and the data coming from different sensors and sent to different actuators is stored somewhere, and that data is not garbage. That is very important for analysis. Then what how that data will be used, the analysts can can observe and can analyze the data and identify which problem has occurred at what time. So in the future, to avoid such kind of errors, certain modification in the system can be done. After sensing, we have to do decision making. In decision making, there are mainly two type of uh, automation methods. One is rule based automation and another is AI based automation. Before I differentiate them, I would like you guys to see both flows and tell me what is similarity in both the blocks, this and this. Hmm? So sensors and actuators are common in both cases, right? But there is difference, major difference is control section. In rule-based automation, the designer applies some rules. Like for example, if the weight is less than 100 gram, then the package will be diverted from one conveyor belt to another. Or for example, if the temperature is greater than 30 degrees centigrade, or then the fan will be turned on. So these are certain rules. So in rule based automation control system, the designer sets all the rules, all possible rules. But in AI driven automation, we have machine learning based controller. In machine learning based controller, what we do, we provide old data of that particular system to that machine learning algorithm, and that machine learning algorithm will identify a relation between inputs and outputs, and based on that learning the model will be trained, and in the future we can use it in real situation. That is called deployment. So once that model is deployed, the trained machine learning model is deployed, it will be behaving exactly same as the data we have given this while training, right? So in AI based automation, the data coming from sensors is exactly same, and actuation will be same, but the controlling process will be different. That will not be based on if and else. If we conclude them, rule based automation and AI driven automation. In rule based automation, all the engineer defines every condition, all possible conditions. Like if this happens, then this should happen. If this happens, then this should happen. So there will be a big set of if and else statements that will be covering all possible condition of that particular system. But in AI driven automation, the engineer defines the goal, and the system learns the behavior, and that system is based on machine learning. After decision, as I mentioned earlier, the action will be performed. Now, in order to perform the action, there are different actuators. So actuators are components that perform physical action, and these are uh, devices that those convert electrical control signals into mechanical movements. So what are the examples? One example is motor. We apply electrical signal, and based on that signal some rotation will be done. So we can use motor in a conveyor belt in order to move the products on the conveyor belt from one place to another place, right? Another actuator is electromechanical valve. The purpose of this actuator is to control the flow of fluids or air. Fluids can be petrol, can be diesel, or even we can use miniaturized electromechanical valves to control the flow of blood in different medical applications. Another example is we use different kind of actuators in robotic arm. That can be motor, there can be spray, there can be soldering machine, that can be welding equipment. So these actuators will be working based on the decision made by the controller, and the controller can be AI driven or it can be rule based, right? So far, what we saw sense, decision making, and action performing. Now, I would like to ask you guys in your real life, where do you observe sensing, decision making, and performing an action?
We are taking an example of playing cricket. So in cricket, we firstly sense what? Sense the ball length, and line and length and the speed of the ball. ठीक है? And then we will decide what to do with the ball. Are we leave the ball or take a shot?
In order to wrap up, there is a quote by Bill Gates. He said, automation applies to an efficient operation will magnify the efficiency. We have seen in today's session that by the time automation got more efficient by utilizing different sensors, different actuators, and advanced control systems.